Right. So let's continue with our MLOps tutorial series. As of now, we had seen how to use Git. We had seen Streamlit. Next, we will work on machine learning project, and later on, we will combine all these three things. Okay, so that we can see like how we can use our ML apps, okay, or whatever the machine learning app or whatever the machine learning model that we create, how can we use it at the production level. All right, so let's continue with the thing here. I already mentioned all the steps, general steps that we basically use. Why do we use while working on a machine learning projects? Okay, like for example, first we import library, then we read the data, then we identify the data columns or whatever the columns that exist in the data. Okay, identifying the target column, shape of the data, name of unique items. Okay, so these are the general steps that we generally use, okay, when we work with a machine learning project, right? So let's continue with the same thing. First of all, we have to import the library. So for importing library, we generally import what? It's like, import pandas as pd, import numpy as np, right? Next, what? See, here we will not perform much EDA, so matplotlib is not required. Okay, so next we can do what? We can just use over here SimpleImputer, right? So from scikit-learn .impute import SimpleImputer. Why do we use it? So that you can fill up the blank or you can say null values, right? Next we have what? For scaling we can use from scikit-learn preprocessing import MinMaxScaler, right? And yeah, for encoding we can use LabelEncoder. All right, so the whatever the project you are working, okay, generally we have to use these modules. All right, so now we imported the library. Next we have to read the data, right? So for reading of the data, already I uploaded the data over here in the same folder in which our Jupyter is running, right? So if you see, data is already there, loan train and loan test. Okay, so let's try to read the data over here, df loan. Okay, so df loan is equals to what? pd.read underscore csv. Okay, and here I can feed what? The data name. All right, so data name is what? Loan train dot csv. Okay, and then df loan dot head. Okay, I did a mistake. I missed the quotes over here. No worry, df loan dot head. All right, that means we can read the data. Now, what is this data about? If you say we have a loan ID, we have a gender information, we have a married, unmarried information, dependent information, like how many dependents one is having, education information, self-employed, whether someone is self-employed or not self-employed, whatever the income one is having, co-applicant income, loan amount, how much basically the person actually took, loan amount term, credit history, property area, and the status of loan, whether the loan was approved or not approved. So this is a historical data. So based on the historical data, we have to build up a kind of a model which can decide whether loan should be approved or it should not be approved. Okay, so this is our project that we are going to work upon, right? So we did what? We imported the library, we read the data, then we have to identify the data columns. So let's go ahead and try to identify the data columns. All right, how do we identify the data columns? To identify the data columns, we can use df loan dot columns. All right, so this is my data columns, right? These are my data columns on which we have to work upon. So obviously loan and status is going to be a target column. I just need to identify over here that in a status column, or you can say loan status column, how many unique values are there. Okay, so loan status dot unique. Okay, so we have two unique values, y and n. Okay, looks good. Okay, what are the count of each of them? Let's see. Dot value counts. Okay, so this is a value count we have. That means we have most of the time loan was approved, and there are some times when the loan was not approved. Okay, so we have a data that has been given. Now we have a shape of data. For that we can do a df loan dot shape. All right. Okay, so we have 614 samples over here. Number of unique items in each column, df loan dot number of unique. Why do we need it? Number of unique items we need it so that we can decide which column is categorical and which is non-categorical. Now let's create a copy for original data. Why it is so? Because now we are going to make a lot of changes in the data, and the original data I don't want to disturb. Okay, so that suppose in future, if because of any case I can't load the data, so let's say I'll do what df is equals to dfloan.copy. Okay, and then just verify if it is being created or not created. So it's so that I had successfully created the copy of original data. All right. So once it is being done, okay. Next, what we can do, we can drop the duplicate data columns. How can we drop duplicate data columns? It's like we have df dot duplicates. Okay. So it will return me true or false. Let's see. Or it is a duplicated, right? It's not duplicates, it's duplicated. Okay, so we're getting an error because spelling mistake we are doing, duplicated. Okay, so we get true or false. Now let's pass this thing through the actual data. So we don't have any duplicate value, that means it's good. Okay, we need not to remove any duplicate values. Now let's come to the missing values. For the missing value dot isNA dot sum. So when we check the missing value, we have a lot of missing values over here. Right. Now let's try to identify numerical and non-numerical columns. How can we identify numerical columns? df dot select d types what numbers. Okay. So let's see. Here it will just select all the numerical columns, but it is not selecting numbers. Is not understood because it may be number one. Okay. So these are our numerical column. Okay. I can just separate the columns from here. Okay. Alright. So I can just use this thing numerical columns. Same way I want what non-numerical columns. So df dot select d types. Okay. Exclude number. So these are non-numerical column, right? So I can use what non-numerical columns. Okay. So now we had separated our numerical and non-numerical columns. That means the columns name you can say numerical columns. Okay, and thereafter print on numerical columns. Okay. So we had separated it. Okay. So now why we separated it? Because if it is numerical column and we have to remove the missing value, we can use what? Mean, right? And if it is non-numerical, then we can use mode. Okay, that is the reason we have separated it. We can just convert this thing into list as well, so that later on processing can be more smooth. All right. Okay. Now I have to fill up the missing values with the SimpleImputer. So for filling up the missing value of the SimpleImputer, what we can do? I can just define an object over here. Let's say I have to kind of impute for the categorical column. So I can use categorical imputer is equals to what I can do. I can just use SimpleImputer that we already imported. Okay. And here I have to define what strategy, right? So a strategy, we can use what simple mode, or you can say most frequent. So whichever item is most frequent, that can be used, right? Now with this object I can do what? Categorical imputer dot what? Categorical imputer dot fit. Okay, we can just pass the data over here, df what? The non-numerical columns, right? Non-numerical columns. Okay. So once we fit it, thereafter what I will do, I will transform, right? Or I can directly transform here also. Transform. Right. So now we have a data that is being updated. Okay. So these columns of my data I want to update with the most frequent value. Okay. Same thing for the numerical. I can do what? Numerical imputer. This will be equals to what? Again SimpleImputer. Okay. And thereafter I can use a strategy. Here it can be what? Mean value I can use. Right. And thereafter same thing, df of numerical columns is equals to df of numerical, or you can say numerical imputer dot fit underscore transform what? df of numerical columns. Okay. Now let's check if anything is missing. df dot is na dot sum. So all the values are fixed. So we fix up the missing values. From here I have to do few steps. I have to perform the encoding for all the non-numerical columns. Okay, I have to remove any unnecessary data column, log transformation, then perform data scaling, and then we can build up the model. So these things we'll do in the next video. Okay, till then, just try to continue from here on your own. Okay, and let's see how much successful are you. Right. So very soon we'll go for the next video where we will try to finish this particular model. All right. Till then, take care. Have a great learning.